Hi class, we have the seventh lesson for indices today. We have two problems I want us to solve. Yeah, this one is a fraction. This one is a fraction, but with individual powers. Here we have a power here that affects everything. This power 3 is only affecting the bottom left base, which is x. It doesn't affect it. Minus 2 only affects y. Minus 1 only affects x, 4 only affects y, minus 2/3 affects everything inside, including the numbers. So, but the power here is negative. Yes, we can now take care of it. Yes, or we simplify internally first, then later we take care of it. But whatsoever we do is just the same. So, whenever the power is a fraction, whenever the power, sorry, not the fraction, whenever the power is negative, we can take the inverse of this. Instead of this upon this, it now becomes this upon this. So we say 27x to the minus 1, y to the 4. This is not the case where you change the sign of the power because of moving it to the top. We are moving it to the top, this to the bottom because of negative power here. So over what we were having at the top is 8x cubed y minus 2. So once you interchange them, you forget about the minus. It is now 2 over 3. I hope it is clear. So what is next is let us separate the numbers. We say 27 over 8 multiply. Between 27 and x, no sign is written. It means multiplication. Between x and y, no sign is written. It means multiplication. And the lucky side is that this x, we have it here. This y, we have it here. So we can just use 1x. This is multiplication side, mind you. We can use 1x. Here we have minus 1. We are using 1x, but we prioritize the one at the top, minus 1. So if this one is going to the top, we are not moving the x again because we have already decided to use 1x. Only the power that is moving. And moving the power, the sign has to change to minus 3. So y again, we use 1y times y to the power. The one at the top is 4. We always write the one at the top without changing the sign when you are trying to unify what? The same variable here or the same letter. This minus 2 goes to the top. The sign changes to plus. Yes. So we have 2 over 3 here. So 27 over 8 times x to the power this and this minus 4 times y to the power 6. Then we have 2 upon 3. I hope it is clear. Okay. This is the second problem. All right. So in that case, this power here is meant for every time we have every value we have in the bracket. So if this power is meant for 27, we say 27 over 8 raised to the power 2/3 this to this times x to the power minus 4 times 2/3 times y to the power 6 times 2/3 because this power outside is meant for all of them. Okay. 3 here is 1, here is 2. Unlike 3 and 4, we cannot do anything unless we say minus 4 times 2, which is minus 8 over 3. So now, look at what we have here. 27 and 8. 27 can be written as what? 3 to the power 3. And 8 can be written as 2 to the power 3. all raised to 2 thirds. Then this is x to the power minus 4 times 2 minus 8 over 3. This is y. 2 times 2, we say 4. So if this power 2 thirds affects this 3 to the power 3, what do you think? So it will be like 3 to the power 3 if it is also affected by 2 thirds times 2 over 3. So this and this will go, leaving 3 to the power 2. So we say 3 to the power 2. The same thing goes here. These 2 to the power 3 are affected by 2 thirds outside. It will be like this, 2 thirds. It means 2 to the power 2. So 2 to the power 2. You see that? So this is x minus 8 over 3 y power 4. So 3 to the power 2 is 9. 2 to the power 2 is 4. X to the minus 8 over 3 y to the power 4. I hope it is clear. Okay. So let's come to this one here again. This x is affected by 3, y affected by minus 2, but 2 thirds is for all of them. X is affected by minus 1, y is affected by 4, but half is for all of them. So what do? We say this x raised to 3 times the one outside, 2 thirds, y raised to minus 2 times 2 thirds times x raised to minus 1 times half, y raised to 4 times half. Okay. Can we apply this method we have here? Let us do apply it because we already have a fraction. Apply this one will generate another fraction. So let us maintain this one. So x raised to 2 times this one outside minus half, y raised to minus 3 times minus half. So 3 takes away this, leaving x to the power 2. 3 and minus 2, no cancellation is possible. So minus 2 times 4, minus 2 times 2, minus 4 over 3 times x to the power minus 1 times half minus half. 2 into 4 is 2. 2 times 1 is 2. So this cancels this one. So we are left with x to the power minus 1 here. So minus times minus is plus. 3 times 1 is 3 over 2. Do you see that? Okay. So what we do is, this x and this x, let us combine them. A to the power 3 times a to the power 4. The bases are the same. We take 1. Because of multiplication, we add the powers. So x we take 1. Yes, both are at the top, mind you. X we take 1. This is 2. But because of multiplication, we add the powers. Plus what? Minus half. Y we take 1. Yes, this is minus 4 over 3 plus these 2 here. Then here is x to the minus 1, y to the 3 upon 2. Okay, so we keep going. This is x, this is 2, plus times minus is minus half, and this is y, minus 4 over 3 plus what? 2. Minus 4 over 3 plus 2. So this is x to the power minus 1, y to the power 3 over 2. So we say x to the power, what is 2 minus half? we have 2. They take away half. There will remain 1 and a half. And 1 and a half is 3 upon 2. 1 and a half is 3 upon 2 because 2 times 1 is 2 plus 1 is 3. So 3 upon 2 y to the power. Okay, so this is minus 4 over 3 plus 2. Minus 4 over 3 plus 2 will give this 1. The LCM is 3. 3 into itself is 1. 1 times minus 4 minus 4. This plus is this. 1 into 3 is 3. 3 times 2 is 6. So minus 4 plus 6 is what? Is 2 over 3. So 2 over 3. Now the denominator we have x to the minus 1, y to the 3 upon 2. Okay, that one is 2 upon 3. This one is 3 upon 2. All right. So we keep going. X will take 1. Let's take the one at the top. X, 3 upon 2. For this one, x is not going, only the power is going. So when the power goes up, the sign changes to plus 1. Y will take 1. The one at the top is 2/3. When this one is moving, y is not moving, the power is moving. When this power goes up, we say minus 3 upon 2. So x to the power 3 upon 2 plus 1. 3 upon 2 is 1 and a half. 1 and a half added to 1, we have 2 and a half. 2 and a half is 5 upon 2. All right. So this is 2 upon 3 minus 3 upon 2. 2 upon 3 minus 3 upon 2. The LCM is 6. 3 into 6 is 2. 2 times 2 is 4. 2 into 6 is 3. 3 times 3 is 9. But 4 minus 9 is what? Minus 5. So minus 5 over 6. So this is what we have. Yeah, indices is one of the trickiest topics we have in mathematics because we have different ways to solve or to simplify indices. Lot of ways. You only need to what? So many ways. You only need to be able to remember all the principles. Thank you for watching. Don't forget to follow, like, share, and comment.